All right. So, hey everyone. Thanks for joining in on a Saturday evening on a very long weekend in Malaysia. I'm Fuzz and I have Thiru along with me, and we are co-organizers for Cloud Native Malaysia. For folks who joined us in our first meetup last, I think it was when was it? March, mid of March, I believe. You would have
Yeah,
you would
bit
have
of
met
March.
us you would have met us in the office in at a previous venue. We life happened in the middle, COVID happened, a lot of other things, and we started bringing back some of these meetups in a virtual format, just to see how what the uptake is, because we still see there is a kind of a you know an ask or a need in from folks and understanding what's happening in the cloud native space. But before that, Thiru, what were you doing for the last 6 months?
Thanks, Fuzz. Hi, everyone. It's nice to be able to do this. And like Fuzz said, COVID happened. All of us got stuck in our houses, and some of us took it far worse than others. Others were pretty happy to stay at home. But for the most part, I guess we have to get used to the new normal. So, guys, please wear your masks when you go out. So what have I been doing for the last 6 months? I actually started a new job, which is fun. Faz and I are colleagues, in case anyone's wondering. And life's been pretty good so far. And I hope all of you guys have been keeping up with the times and having fun as well.
Yep.
Yeah.
Awesome. Thanks for that, Thiru.
So-
The fact that everyone should be safe during these holidays also. Wear your masks, sanitize your hands, and other things.
Yeah. Wash your hands too.
Yeah, and whenever you can't sanitize them, wash them. All right, cool. With that, let's jump into a couple of housekeeping rules. So here's a standard mandatory slide of ours, and a couple of housekeeping rules. We don't have Slido today, but yeah, we'll skip that for now. Feel free to ask questions on the YouTube comments. YouTube comments are there on the right side or left side, whichever way you're seeing it. And if any questions, any comments, feedback, just put it in YouTube, and we'll highlight it in the session today. This live stream will be available on Engineers My YouTube channel. That's if you're already watching this on YouTube. This is the Engineers My channel on YouTube, and this will be available for future viewing also. And also from a community perspective, be respectful to each other. Don't do flame baits in the comments. Don't do bike sharing, saying that hey, you know what, Istio is better than Open Mesh or something like that. I mean, I'm not sure which one is better, but yeah, whatever works in that case. And with that, I just wanted to thank Engineers My as a sponsor. Engineers My has actually helped us in providing a platform where we can stream all these meetups virtually. The fact that not having a physical space right now, or even the right kind of SOPs to do meetups, kind of makes it tedious to reach out to the community. So using platforms which we're using right now kind of helps. So the community came in together and then matted together for this. So thanks to Engineers My for that. Do join us on Slack. Engineers My, you can just search on Google and you'll be able to find the Slack page. Join in. It's a very vibrant community. We don't bite over there. Definitely stuff we can discuss on. With that, we'll just directly jump into our first section before we introduce a speaker, which is Buzzcorner. And this is a concept which we took from other communities that have been running it for quite some time successfully. And the idea with Buzzcorner is to bring you the latest and greatest that's happening in the cloud native space in the last 1 month, 1.5 months, anything that's thought-provoking, anything that's a very vital announcement, which we think is vital. And also, in our case, because we haven't been around for a couple of months, this may seem kind of like a collage of announcements we have done in the last couple of months. First up, we have K3S that's joined CNCF. And for folks who don't know, K3S is basically a lightweight Kubernetes distro. It's by Rancher Labs, and they just announced they had applied to CNCF 3 months ago, I believe, and then they got accepted into the sandbox project just 2 days ago. So this is from 28th of August. Pretty latest news, and this is awesome in a way because it allows K3S to also now start becoming, apart from being anointed by CNCF as part of the ecosystem, it allows K3S to also start being contributed to directly much more by official contributors at CNCF, because I believe Rancher Labs was acquired by was it VMware or Cisco? Who was that? Do you
I think VMware was no, I'm not entirely sure, but yeah,
remember? Okay.
you're right. It's one of those two. So I'm not actually sure if Rancher did get acquired.
Oh, right. Suzy. So Suzy Linux acquired them. Yeah.
Right. Right. Okay.
Yeah. But you
so, oh yes. So that means no. So sorry, go for it.
Right. So K3s is a very good way to get started with the Kubernetes ecosystem. The fact that you don't need to install plain vanilla K3s, it is a bit opinionated, so it does certain things on your behalf. A really good way to just get this started on your laptop or even on a Raspberry Pi, as I've heard folks do for some time. So do check this out. It's a project that's there right now in CNCF also. Next up, there was a state of cloud native development report that was released a couple of months ago. And this is an interesting report because it talks about the whole ecosystem of cloud native and with how Kubernetes is being used by developers across the globe. And some key insights from this report is that there are 6.5 million cloud native developers around the globe. So which kind of starts showing that, if you are not already working with the cloud or on the cloud, you should definitely start considering it in some form or the other. 1.8 million more than Q2 of 2019. So it has definitely grown compared to Q2 of 2019 in the last 1 year. And 2.7 million developers are using Kubernetes already. And from that, 9 out of 10 developers are using container orchestration tools, and they are aware of Kubernetes. So in the container orchestration realm, you have a couple of tools that are already available, right? Outside of CNCF, if you look at Docker Swarm is one option which is still available for orchestrating containers. And then you have similar smaller projects of that end. And then you have cloud providers also providing their version of orchestration also. For example, Amazon has something known as ECS, apart from also providing Kubernetes. You would say that almost anyone who's touching container orchestration, they would already be touching Kubernetes in some form or the other, and they are aware of it. But surprisingly, there are a certain amount of crowd that is using this, but they're not aware that they're using Kubernetes.
I think Faz is having some trouble with his internet connection. Let's just wait for Faz for a bit.
You guys can hear me? See me? I'm here. Hello. Let me just see. Oh, okay. Yeah, Thiru, I think it's a problem at your end. Yeah. Yeah, okay. He's gone spinning. Fine, fair enough. No worries. Yeah, so one of the perks of doing a virtual session is the internet has to play good with us. Right. So out of these developers, 4 million developers are using serverless architectures and cloud functions already. And this is growing, right? The fact that you have a lot of companies, whether they're startups or whether they're enterprise, who are looking at new projects or trying to re-architect their applications, are considering serverless as a first option, at least in some form or the other. I have been talking about serverless for the last 3 years. People who know me in the community already have seen this. And it kind of feels like, okay, it's taken some time, but now serverless is kind of mainstream in some form or the other. Any person who is not too familiar with the cloud still knows about the concept of serverless. So it helps you to actually understand that there are different ways of building architectures and applications right now. 46% of these serverless users are using AWS Lambda, and 62% of cloud native developers are using AWS as a cloud hosting provider. So it kind of gives you an idea of where the balance is shifting, right? From a cloud provider perspective, all three cloud providers, they provide a lot of services already, so you can't go wrong in either side. More or less, it's about specifics where you would want to go and then choose a specific cloud provider. But that being said, the fact that Kubernetes is being driven just by this cloud adoption is kind of big in its own way. And you can also see 60% of backend developers are now using containers by default. A lot of developers use containers in their laptops so that they can develop locally, so that they can host it in production later. It makes it easier for them to push things directly. One other thing from the report is that cloud native is more widely used in Europe, America, and Oceania, but it's also gaining traction in the Middle East and Asia. And for us in Southeast Asia, we can already kind of see that trend. Whether it's a big company, whether it's a small company, you're talking about small and medium businesses, they all are talking about Kubernetes in some form or the other. And they are trying to build their applications cloud native, so cloud first at least, as much as possible. In this case, you have containers, you have cloud functions, and then you have container orchestration tools and management platforms. 59% of backend developers have used containers in the last 12 months. Only 27% of developers have used Kubernetes to manage them. So when it comes to all these developers using it, you're kind of seeing that as part of the job description when people are getting hired, right, in companies. And then even when you're also looking out, that Kubernetes in some form or the other is being asked. One of the things we noticed in the community for the last 1.5 years is every time we ask this question, what are the top topics you want to learn? Unanimously, whether it's a college student, right, or a fresh graduate, or someone who's tenured in the industry, one of them would at least always say Kubernetes is something I want to learn, even though they don't know much about it. So it kind of shows that we are reaching that maturity point, at least from an awareness perspective. The tooling, as you can see, like every couple of months we keep having a new version. So yeah, and popular CAS container as a solution services have Kubernetes engines running under the hood in some form or the other. You see all the cloud providers already in this. So you have AWS, Google, and Microsoft, and then Red Hat also through their OpenShift platform, and Pivotal through their container service. And then you have the others like Docker Swarm and Mesosphere and Helios, which is still being used in some form or the other. And there was also a recent job description that had come in from a company, a very popular company, depending on which part of IT you are in, where they asked for 12 years of experience in Kubernetes, even though Kubernetes has been out since 2015 officially in the open source community. So people have jumped the gun even on what's the years of experience required for Kubernetes. It doesn't mean that, okay, you actually need to have to compress all the years of experience into 12 years. I mean, it doesn't work like that. But it kind of feels like it was just a mistake of where to put the semicolon or the comma. So in this case, you could already see when people are already talking about job descriptions and having more years of experience, it starts looking similar to another trend that had happened many years ago. If anyone remembers the agile trend, where everyone wanted to become agile, and now everyone is kind of agile, kind of, depending on which definition you go with. So you would say Kubernetes is the new agile, right, in that case. Yeah, I mean, that's the state of cloud native development. It's a big report. It's already available on the internet. You can just search for this. We'll put the link later on YouTube for you to have a look, so you get an idea of what's happening in the space. Another thing that's happened in the ecosystem was we had our first KubeCon Cloud Native Con virtual conference. This happened on the 20th of August. It was for 2 days, 18th to 20th of August. It was for 2 days, and it was pretty awesome. Had a pretty big turnout. There is a lot being written by folks who attended it, saying that how this thing was managed very well. You had keynotes coming in from organizers like Priyanka over here. There was a lot of engagement happening on Slack already. And you can see from this case that in Slack, what they did was per session, they had actually created channels, which was pretty awesome. And you're kind of seeing this now, this form or mold of how to create a virtual conference happening already, where people are leveraging off of tools that are there, like whether it's Slack, whether it's Discord, to run conferences like this. I myself have attended a serverless conference a couple of months ago, where Discord was the main communication channel. So every speaker would get a channel of their own. So it was pretty cool to see that, and seeing CNCF already doing that kind of shows the way for us if we want to run a similar conference at our end in this area. So anyone who's willing to step up and work with us to do a mini KubeCon in Southeast Asia, even 2020, do reach out to us. We are definitely hearing. Just to show you the amount of schedules that were done, these are the kind of types of filters, right? The type of talks that were done on KubeCon over 2 days. There's a lot of talks over there. And if you just go to their website and just have a look, you can access this right now. The slides are also available. The videos apparently will be shared on, I guess, YouTube by September. So that's another a week or two down the line. And you'll be able to see the latest and greatest of what's happening in the ecosystem over there. So next up, we have the technology radar. Thiru, you're taking this, right?
Yep. I will take this. Thank you very much for that, Faz. So, for those of you who have been in the IT industry long enough, you might have heard of a company called ThoughtWorks. So, ThoughtWorks is sort of like a research and market research organization that discovers new and interesting technologies about within the software space and publishes a report on a regular basis. So one of the things that they came up with is something called the technology radar. So as you can imagine, the technology radar is sort of like a graph that talks about newest technologies followed by technologies that are just being started to that are starting to be adopted, followed by production ready and enterprise level support sort of things. So the CNCF also came up with something similar to the ThoughtWorks technology radar, and it also looks very similar. So first, next slide, please.
Yep.
So it looks something like this. So this particular image talks about this CD space. So continuous delivery platforms in the CNCF landscape, if you will. So organizations are starting to assess applications like Spinnaker or Tecton and stuff, and you might be wondering, how is it that Jenkins is there? I mean, everyone and anyone is using Jenkins and things like TeamCity and so on. But this is more from a CNCF perspective, more from a cloud native perspective, which is why you are seeing more and more well-established pieces of software like Jenkins and TeamCity over there. So organizations are trialing GitLab, whether it's on-prem or GitLab as a service, and Helm from a Kubernetes and cloud native perspective. Helm is one of the best ways of deploying software into your Kubernetes cluster. So that's why Helm is right up at the top. So next slide, please. Right. So the other announcement we'd like to talk about is something called Open Service Mesh. So the service mesh space is heating up pretty aggressively. Now we've got a lot of different service meshes for you to play with. The interesting thing is that all of those service meshes are, or at least pretty much most of those service meshes are powered by Envoy. So our speaker will probably talk a little bit more about that later when he starts his session. But Open Service Mesh is something that Microsoft open sourced, and it's a worthy competitor to the likes of LinkerD and Istio as well. So next slide, please. So
Microsoft.
Those of you who've been following what Google has been doing with open sourcing Istio is that Google still maintains governance over Istio, and governance is it's essentially not fully open source, unlike Kubernetes. So a lot of people in the open source community have taken issue with that. Essentially, what that means is Google still holds the keys to the kingdom as far as Istio is concerned. So Microsoft
similar to another one,
gone the other way. Yeah, so Knative is something that Google holds, and so far we haven't had Knative as a service just yet, except for maybe Cloud Run. But by and large, there is no Knative as a service just yet. So that's something that Microsoft has done differently. So again, pretty much the same concept as every other service mesh. You've got the control plane, you've got the sidecar proxies in each container that you run. The control plane and the interfaces can be provided by service mesh, Istio, LinkerD, and so on. But ultimately, the telemetry and all of the information that is collected within and about those services all come from Envoy. Okay. Next slide, please. Right. So now it's time for us to introduce our speaker for this meetup. His name is Shardul. He is from REA Asia, and today he will talk about the advantages of using LinkerD or Istio. So, Shardul, thank you, and stage is all yours.
Thanks, Siru. Thanks a lot. Hi, guys. Thanks for joining. Okay, I'll quickly share my screen.
Okay.
All right. All right. I'm going to talk about service mesh today. One of the most famous buzzwords right now around Kubernetes and ecosystem, and also I'm going to talk about Istio and LinkerD. These are one of the best service mesh technologies out there right now. I'm gonna tell you about it. Some before even getting into the details of service mesh and all. I'm gonna get into some details about the past, what we used to do, and how did we even arrive at a situation where we needed a service mesh. And then I'm gonna talk about Istio and LinkedIn, and then some comparison between them. In the past, we used to have monolith applications. All those applications, big applications. I guess 6 or 7 years ago. Even then, there were some people using microservices. But the problem with those applications were they were huge applications, and all the functionality. Let's say an application incorporates two functionalities. Two different kind of functionality. They were all in the same application. It's all bundled together, and it used to be easy at that time because if you have two functionalities, then you don't need to separately manage them. So there was less overhead of managing them. So whenever there was a change, they would just put it out. They will just deploy the entire application and put it out. It used to be easy, but the problem started when this application with two functionalities became an application with 100 functionalities. So the problem started wherein you have everything all together, but there are 100 functionalities. How do you manage different functionalities? If you want to update one functionality, you have got to take down the entire application down, which was problematic. So that those were the problems with the monolithic architecture. So application, all the functionalities, the entire application was very tightly coupled, and you are bounded. You cannot move from one framework to another. Second thing, if there's a problem within one part of the application, entire application goes down. So that used to be a problem when we were using monolithic architecture. And then came microservices architecture. Microservices architecture, we started having different components for different functionalities. For example, chat service will be a different component altogether. Different functionality for other functionality that you are using, right? So every functionality is independent, and you have a different CI/CD for that. So if you want to update one part of the application, you could just independently do that. You don't have to bring down the entire application just to do it. So that was the good thing about microservice architecture. And we have different database coupled differently, and then there's a logical part is totally different, and even front end is different. In the monolithic architecture, front end, back end, database interaction, everything is coupled together. But microservices are hard because when you have different APIs for your application, then networks plays a very important role here, because essentially one API is talking to another API. Previously it was inter application interaction, code, one code is calling another code. But now it's not a code anymore. It's like one API is calling different API, and it may call different other APIs also. So it's a huge complex traffic flow around the very complex enterprise application. Now when this something like this happens, right, so you have a lot of network complications, such as how do you route your request. You have load balancing. You have to authenticate, because when you have different components for different functionalities, they a functionality has to know that the request that is coming to it is a authenticated request. So you have to add authentication on top of it. If you want to, let's say you have created a new feature and you want to test it only a fraction of the entire traffic, you cannot do that. How do you do? So this is called A/B testing. So how do you do that? You cannot do it. So see these diagrams, right? So let's say you have three versions of application, V1 and V2, and you want to differentiate the traffic. There are two pods in the same with the same version, and there's one pod with the different version. So you can always manage the traffic, but you cannot say that one version will get 45% and the version get 45% and another version get 10%. This is not possible right now, because microservices, you have actually, it is doable, but it requires a lot of effort. It requires a lot of coding, and you have to manage everything by your own. And so this is the problem that service mesh is aiming to solve. Now comes service mesh to solve this problem of managing the traffic, because as I mentioned, right, there are a number of things: request routing, authentication, load balancing, everything is there. How do you manage all together? If you do everything by yourself, you're gonna in turn gonna create another huge solution by yourself, which may or may not work. So that is where service mesh comes. It's a solution, and it is a dedicated infrastructure layer on top of your services. It manages a communication between your services, and it apart from that, it also provides service discovery, authentication, authorization. And there are tools which that I'm going to talk about. They have a really good monitoring and tracing features. Okay, how does service mesh work? So in Kubernetes environment, even in other environments as well, there's a pattern. It's called sidecar pattern. So I'm going to talk about when I'm talking about service mesh, right, I'm going to talk about more into the context of Kubernetes rather than different contexts like Mesos VM, because in this context it's better. Anyway, we are talking about CNCF, right? So in a Kubernetes pod is the smallest unit in the entire cluster. But a pod can have more than one containers, even though that is not the right way of doing things. That is why there are several patterns of how do you manage your containers. So a pod can have one or more containers, but the best practice is that you should only have one container per pod. Apart from that, if you want to have multiple containers, there's a pattern to it. So there are several patterns, such as ambassador pattern, adapter pattern, and sidecar pattern. So one of those patterns is sidecar pattern, in which you run another container separately from the main container. So instead of running it into the cluster as a daemon set or anything, or another pod also, you run it into the container itself. So another proxy container will be running there. And that is how a service mesh works. So every pod, so let's in service mesh, every pod will have another proxy container. So every pod will have two containers. Let's say it has one container, so it will have two containers from now on. So let's say your service has three pods: container A, container B, container C. So in all those pods, there'll be another service proxy container added. It's as a sidecar, and that is called the sidecar pattern. And they together work as a mesh network. Okay, so I'm gonna talk about more into the how it works and everything, but before, probably I think it's best to take an example such as Istio. So one of the most used service mesh technologies out there is Istio. Istio is the number one technology right now. Istio was open sourced by Lyft and Google and IBM in 2017. So it's a service mesh designed to connect and secure the microservices. Istio has a lot of features. Istio has, you can do a dynamic routing between services. Just to give an example of dynamic routing, Let's say you have developed an application, and you want to make sure that you want to get it tested by one of your esteemed clients, maybe someone that you want to test it, before you even roll out to the wider audience. Now, how do you make sure that happens? So I you want to you already have a version 1 and you have created version 2, and you want to, whenever the that esteemed users of yours, whenever he logs in, you want him to see the version 2 of the application rather than version 1, so that he can test it and he can give you feedback on how is the application, how's the flow, and how good is it, the feel of it. And this is something is called dynamic route configuration. You can do it in Istio. You can just say the header of the user, and then you can define the version in the configuration, and automatically whenever that user logs in, the user will see the version 2. A number of features are there in Istio. A to B testing. You can a fraction of your users traffic will go to a different version of your application altogether. That way you can understand the response, you because you can see whether your people are liking your new interface or not, and all those things. That is something Facebook does quite often. Canary releases, you can do canary releases with that also. And good thing about Istio is it provides you so many of functionalities, and at the same time it can become really really complex. So if you have a very complex scenario for traffic routing stuff, and if you want to if you want to enforce some organization policies as well for for the service interaction, then you can do all of that in with Istio. And with Istio also you can get all the logs, and Istio even comes up with its own Prometheus and Grafana. You can see the dashboards. Okay, Istio architecture. So this so just like Istio, every service mesh will have two parts: a data plane and a control plane. If I am to explain that, data plane is the proxy itself. The container where the proxy is running as a sidecar container, that is the data plane. So all those proxy network, that is what is data plane. And the control plane is another plane where it manages the traffic, the all the the conditions and everything, and even the telemetry data, everything that that gets managed is from control plane. Istio has these components. For proxy, Istio uses another CNCF project called Envoy. Istio uses Envoy proxy. So every container, if you use Istio in your cluster, every container, wherever you want, the proxy, whichever traffic you want to be proxied, there will be one another container, Envoy container will be running there, and the configuration and everything is being managed by the Istio control plane. And on the control plane side, it has three components. First is Citadel, Pilot, and Galley. Pilot is basically a component which is responsible for configuring all those Envoy proxies. There is a component called Citadel. It manages the certificate issuance and rotation. So basically, it manages the TLS communication between those proxy containers. And there's Galley. So Galley is something which basically transforms all the configurations and into something wherein Istio can understand that. So it is that component. It basically validates and transform that configuration into Envoy proxy configuration equivalent, so that Envoy can understand that. So it does all those transformations for Istio. And as I was mentioning, right? So this is the architecture. So you see, there's a control plane. It has Pilot, Citadel, and Galley, and then these are your applications. So basically there's a service A and service B, and there are two in the same pod. There's another container. These are Envoy proxy containers. So what happens whenever there's a traffic, whenever the traffic comes in, it is intercepted by the proxy. It doesn't go to the actual container, and this proxy in turn sends it to the service A, and the egress also is intercepted and then gets it back, and then this traffic is sent to another proxy. So all the traffic goes from proxy to proxy, and the within the pod communication happens from proxy container to your service container. It doesn't happen from service to service. So once you have all these, traffic intercepted, you can do anything. You can do load balancing, you can do authorization, authentication, you can do a to b testing. So that's how it really works. It's all about proxy sidecars. Okay. Apart from Istio, there's one more project which is the second number in the most popular service mesh technologies. That is LinkerD. So LinkerD is one of the CNCF incubating projects. It started as a network proxy, and later uh, it was renamed to LinkerD, and then it became an incubating project with the CNCF. LinkerD also has a lot of features, but as you know, right, there will be different products out there. There will be different technologies to achieve the same thing. The container orchestrations also, even container also, there are number of technologies, right? But everything will have its own distinctions. It provides one thing or another, and that's how you choose which one to use, right? So Linkerd is, the philosophy is that it is a very lightweight, so it doesn't load give load to your existing platform. And for sidecar proxies, because it wants itself to be very very small, lightweight, and very less digital footprint, it uses its own sidecar proxy. It's called linkered proxy. It is written in Rust. So linkerd again provides all those HTTP, HTTP2, and TCP proxying. It also provides load balancing. um, Good thing about this, so, and also it also comes with automatic proxy injection. But the good thing about this is that it comes with the admin dashboard, and it provides all the functionalities that a common service mesh technology would want. But but the most amazing thing about linkerd is that it is um, it is very simple to use. It has a very simple CLI interface. Just get started. Unlike Istio, since Istio is so both are Istio and Linkerd both are created on their own different philosophies. Istio is supposed to be flexible, while Linkerd is supposed to be usable. At the same time, Linkerd doesn't have some features, but it has its own merits, wherein it is better than Istio. Okay. Again, linkerd architecture, it has, as Thiru mentioned before, right, that there's in every service mesh there's a control plane and there's a data plane. So control plane has, in this case, has couple of proxy APIs running, and there are other components running, so they all together drive the behavior of the data plane. And data plane consists of those linkerd proxies. So in this case, Linkerd has one a controller. Controller has number of components such as public API, destination, tab. I'm going to talk about it when I come to architecture. So just to give some overview that these are the part of control plane. There's a web dashboard there, which is amazing that they have it. Istio doesn't have it, and again they come with their own Prometheus and Grafana installation, and with the they have the Grafana dashboard out of the box. Okay, this is the architecture for Linkerd. So you see, right? So in Linkerd comes up with a CLI. So this CLI tool, and there's a web interface as well. So this is what is called admin dashboard. So they come up with the admin dashboard which does everything. You don't have to rely on configuration everywhere. You can see what is going on. And then there's a public API which does everything, which basically this is what CLI and web interfaces with to interact with the control plane. Then there are three components called tab, destination, identity. So every time a request goes to data plane and it is intercepted by the linkerd proxy, it checks with the destination to where to how and where to route to. All the all those conditions that you have added, how and when, all those things. This is what destination tells to the linkerd proxy. Then so there's identity. So identity is a CA, certificate authority, and it manages the rotation of the uh, uh, TLS certificates. Then there's a tab. So I told you, right, that LinkerD is very good at dashboard. So they have a dashboard which Istio doesn't have, and this dashboard gives you the insights, which is really helpful. So LinkerD provides you with a dashboard which gives you a real-time view of the request and responses, and that is something public API uses Tab for. Tab gives the real-time stream of the request and responses intercepted by the proxies. And then there are, proxy injector and SP validator. So these are admission controller. Okay, I'm gonna give some details about admission controller. So, right, I talked about, automatic injection of the proxy. So how does this happen really? In Kubernetes cluster there's a pod, and it pod had its own, container, one container. How does Linkerd or Istio really work that it adds another container within the pod? How is that even possible? Because your deployment manifest wouldn't have that. But how does it do it? So in Kubernetes there's a concept called admission controller. So admission, if you implement that admission controller, every time there's a pod that is to be scheduled, the object will be given, you will be notified, the code will have the trigger for that object, and you can mutate that object then. So that's how it uses works. So basically every time, what Linkerd does is it if your deployment has an annotation called linkerd.io/inject, and if you have kept the values enabled, then what it does, every time a pod is to be scheduled, it intercepts that request using admission controller and mutates the pod spec and adds the proxy with all the proxy configuration. In this case Linkerd proxy, and in case of Istio it's envoy proxy, and then let it get it deployed, scheduled. Now when the container starts, it has two containers now. So this is called admission controller. So apart from this, your Linkerd has Prometheus and Grafana. So all the Linkerd proxy, sends that, basically Prometheus is a, pull based architecture. So Prometheus pulls the metrics from the Linkerd proxy, and there's a Grafana. So it provides you with the out of box dashboard to check all your metrics regarding, traffic and stuff. But if you want to really see, what kind of configuration have you done, how is it happening, everything is using a web dashboard, and it's amazing. Okay, last slide. So basic difference. Okay, okay, right, when it comes to different technologies, it's never a simple this or that formula letter, like, it's always, what do you want, what do you want to achieve, and based on that you can choose technology. For example, Linkerd version 1 supports, even actually it's still continuing, it supports VMs as well. But I'm not sure about Mesos. But Istio supports Kubernetes, VM, Mesos, all three. But Linkerd version 2 is exclusively for Kubernetes. As I mentioned that, Istio uses envoy proxy, and Linkerd has its own Linkerd proxy written in Rust. Istio supports multiple cluster, but Linkerd doesn't have a multi-cluster support. Load balancing is available in both because it's it's crucial, and but Linkerd doesn't support session affinity. That is one of the things that are not there. Okay, one of the good things about Linkerd is it has prerequisite check. So excuse me. So if you want to install Istio, you have to be a platform admin. Otherwise, you cannot install it. And even though you are not admin, but you have all the privileges, you have no way to know until unless your Istio installation has failed that it won't work. That is a problem with Istio, that it is very hard to get started with Istio. I mean, if a normal user is doing it, it will be very hard for him. But on the other side, Linkerd has this something called prerequisite check. You can just do it, and then it will go through all the configuration, all the kind of access that it needs, and it will tell you that okay, you have all the access to install the Linkerd. But that is something not available in Istio, and it's amazing. That really helps you to get started quickly. And as mentioned, right, Linkerd has this amazing admin dashboard Istio doesn't have. Both Istio and Linkerd come up with their own Grafana and Prometheus installation, and observability dashboard with the pre-configured dashboard inside of the Grafana. Operational complexity, there are a number of features which are not supported by LinkerD. So as I mentioned, right, Istio is for flexibility. It provides you a lot of configuration stuff. You can do a lot of configuration, while it may not be available in LinkerD. But all the most, most used configurations that you would need are all available in LinkerD, and it's really good for to get started quickly. But if you have a very complex implementation, then definitely you can go for Istio, and you would be able to achieve it. Okay, there's one more significant difference between LinkerD and Istio, is that, as I mentioned, that LinkerD, the philosophy of LinkerD is that it has to be really small. The footprint has to be really small. That is the reason the it consumes really less power and lower latency. The latency of communication is less. And on the other side, Istio's envoy proxy uses more than 50% of the CPU required for LinkedIn. So it uses more power than LinkedIn. Okay, thank you. Okay, I'll share my screen. Any questions?
Yeah, so there were a couple of questions here. Thiru answered them, but I'll just add them in so that you could chime in a bit. So the first one was on: do you suggest logging should also run as a sidecar?
Thank you very much for that, Shardul. Sorry.
Yeah, there's a delay at your end.
It's okay.
No worries, no worries. Yeah.
So I was answering the question that logging to run a sidecar. I think logging is not really required to run a sidecar. I think if you're talking about EKS specifically, now that we have two AWS architects, I think in EKS you can run it as a daemon set. That's more than enough, I would say. But if you are going for Fargate, then you have no other way than to go for sidecar container, frankly.
Okay. I mean, yeah, you don't have to speak only on AWS. You could speak about the others. It's fine. This is not an AWS meetup.
No,
Thiru,
This is
I can relate to it.
yeah, no worries. No, Thiru, you just mentioned in the comments, you answered some of that, right? You mentioned Sidecar already is collecting this information for logging.
So I mean, logging can be can come in the form of usage metrics. It can also come in the form of observability, right? So Sidecar in the form of Envoy and other Sidecar proxies actually enable that. But basic logging itself doesn't need a Sidecar proxy. You already Fluentd already does it for you. So yeah, like what's on screen right now.
Okay, cool.
Yeah.
And then I think there was another follow up. So you can start using LinkerD for this, for which we have Vilan who's saying
Actually,
that
that's
once
very
you use it,
true.
you can go back.
That's really true. LinkerD version 2 is amazing. I mean, Istio is, as I mentioned, right? Istio is really for a very complex implementation. But if you want to just get started, you don't have very complex. And I'm sure even though you think that there's a complex implementation, LinkerD will still support it, and
Right.
you can very well get started with it.
Right, and he also says that multi-cluster is already supported in LinkerD now, so it's pretty awesome. So that's good to know. Thanks for that. Appreciate it. The fact that folks are contributing into the comments, it kind of shows that there is these topics kind of resonate with the community. There's no questions from in the comments right now. So from my end, I think I don't have anything. Thiru, do you have any questions for Shardul?
So back when I was actively working on Istio, because of the whole multi-cluster support, right? You could actually run Istio, or rather, you could run Kubernetes clusters in different different locations. So essentially, different cloud providers. Do you have any thoughts on that, Shardul?
I mean, you are asking whether Istio supports multi-cluster, or like I didn't get your question.
No. So Istio supports multi-cluster, right? So
Yes,
you can
exactly.
actually put the Istio ingress in front, and then direct traffic into multiple clusters. So you could essentially have clusters all over the place. So whether it's on Google Cloud, whether it's on AWS, Azure, and so on. So what are your thoughts about multi-cloud architecture using that paradigm?
Well, to be frank, I wouldn't really prefer a multi-cloud cluster, Kubernetes cluster. No, I wouldn't
Mhm.
prefer. I mean, if you are using a cluster, I mean, Kubernetes cluster on one provider, then please stick to it because there are lots of challenges of different cloud providers, right? Google GK has its own challenges and EK has its own challenges. And when you have a Istio running in between, you're going to have a mix up of both challenges. So,
Mm-hmm.
perhaps that's not a good idea, I would say.
Okay, fair enough. That's a
Right,
good point.
awesome. So basically, this means we are gonna very soon hear someone speak on why multi-cloud on Kubernetes clusters is not a good idea. So stay tuned for the next meetup.
Yes, hint.
Hint, hint. Cool. Yeah. So I mean, there's nothing from my end. So Shardul, thank you so much for joining us today. I know it's a long weekend. The fact that you've taken some time out of your weekend for this, I really appreciate it.
I hope
Just
it
for
was
the folks.
informative.
Yeah,
You
I
guys,
mean, it was. I mean, totally. Just for the folks over here who don't know, Shardul is. I mean, we know him from before because he attended our first meetup and he supported us in the beginning. So it's great to see that someone who joined in the first meetup is already speaking in over here. So one of the things we want to ask the community over here is to, if you have any topics in the cloud native ecosystem you want to speak on, something you're already practicing or maybe implementing or just trying out, and you want to just share, hey, you know what, this is what I've tried and I think this is how it works best. Or maybe you want to give out a rant or something like we just spoke about, multi cloud Kubernetes clusters. I mean, this is the forum for you. This is a safe space. So do reach out to us. We have our. You can join us on Facebook. So we have a group already available. It's pretty quiet right now because we are waiting for folks like you to join in and make it more vibrant, make some noise over there. We will be now regularly having content. We're gonna start having. Meetups every month. So we're going to schedule one very soon and then notify everyone over here. We'll use the groups as a way to collate other information, feedback, and other things. So any feedbacks, if you all are having, just do put it in Facebook or even over here on the YouTube channel. But with that, thank you so much, everyone. Really appreciate the fact that you spent some of your time over this long weekend with us. Appreciate it, and we'll catch you next month. Yeah. So stay safe. Have a safe holiday. Have a great holiday, and see you soon.
Mm-hmm. Yep. Take
yeah,
care, guys. Thanks.
take care, guys. Bye.
Bye.